Okay, students, so we're here with special right triangles. All right, this triangle to me is very special, and they're also right triangles. So what we're going to talk about, there's two special right triangles. They're talking about 45, 45, 90 triangles, and this is going to be a little foreshadowing and help us out. These are called right isosceles. All right, and how do I know this is a right or an isosceles triangle without even looking at the side lengths? Well, 45, 45. So since two angles are the same, two sides must be the same. And in fact, that leads me up to the right thing. So we're going to use the triangle below to answer the follow-up questions. All right. So again, looking at pictures, very powerful. We have a right angle. I know this is 90 degrees. This angle and this angle are congruent. Thus, we know the triangle adds up to 180 degrees. Since these are both congruent, they must both be 45 degrees. Thus, all the angles add up to 180. All right, so then we use the base angles theorem. Since we have two base angles that are congruent, those legs are the same, so that's 5 as well. All right, so classify right isosceles, kind of already talked about that. How big is each acute angle? 45 degrees. How do we know? We can be very precise and say triangle sum theorem, and then base angle theorem. All right, how long is the other leg? 5, because it's isosceles. There's a bunch of ways we could do it. All right, and then this is the punchline. This is huge right here. We're going to find the length of the hypotenuse, and we're going to leave your answer in a reduced radical form. All right, so again, it doesn't matter which one. We can say A, B, C. In this case right here, let's instead of say A, B, and C, since it's isosceles, just say A, and C. All right, so we're going to rewrite Pythagorean theorem just a little bit. We're going to say A squared plus A squared equals C squared, since A and B are both the same in this case. So plugging in those numbers, I'm going to get 5 squared plus 5 squared equals C squared. And then I got to do a bunch of math. 25 plus 25 equals C squared. 50 equals C squared. All right. And a big punchline of today, or maybe not a big punchline, but some stuff that will definitely assist us moving forward, is simplifying radicals. We did practice those a lot. All right, so I need to find what's the largest square factor of 50. What's the biggest square factor? Well, remember, like we have squares 1, 4, 9, 16, 25, 36, 49. All right, those are perfect squares. What's the largest factor that goes into 50? That'd be 25. So remember, step 1 is write the square factor first under the square root, then write the other factor under the square root, then simplify. The perfect square factor becomes just the square root, 5, and then radical 2 cannot be simplified. All right, and then it said leave your answer in reduced radical form. That's exactly what we did, so I got 5 radical 2. Interesting. All right, I think I see something that's going on here. Can we be certain? I'm not sure. All right, so these are special right triangles. We call them 45, 45, 90 triangles. Hopefully for obvious reasons you can figure out why we call them 45, 45, 90 triangles. All right, so we're gonna find the hypotenuse in each of them below. All right, so this is gonna take us several minutes to do. In the future, this will take you 30 seconds to do all of these. But nonetheless, let's just get after it. All right, boom, boom, 3, found one side. I'm gonna call that C. All right. So 3 squared plus 3 squared equals C squared. 9 plus 9 equals C squared. Take the, oops, got a little excited. 18 equals C squared. Take the square root of both sides. I'm going to write it as C equals square root of 18. And then largest square factor. Maybe I'll just write them all right here. 1, again, these are just the counting numbers squared. I'm going to stop at 64. I don't think we'll need any. No, actually, I'll keep going. 81. I'll do the first 10. All right. What's the largest square factor that goes into 18? That'd be 9. All right. So this is going to break up into the square root of 9, square root of 2, which then simplifies to 3 radical 2. All right. So I found C again. All right. Maybe you want to try the next 3 on your own. Number 5 is a little tricky. Or you can just watch my videos, all right? Remember, you can always pause, work ahead, then check your work. But nonetheless, let's just keep cruising right along. In this case right here, we got 4. So this is 4. And then I'll call that C. This time I'm going to write it as C squared equals 4 squared plus 4 squared, just reversing the order, which is mathematically legal. I'm allowed to do that. And again, just a bunch of computations going on right now. Nothing should seem too crazy. Take the square root of both sides. So C equals the square root of 32. What's the largest square factor that goes into 32? Well, in this case, it'd be 16. Square root of 16, square root of 2, 4, radical 2. All right, there's a definite pattern going on. Hopefully you can figure out this pattern. All right, it's going to make these problems become really quick. And that's why we're learning it. It's like a cheat code that we're learning. And this one right here, we have 9. So this must be 9. Call that C. C squared equals 9 squared plus 9 squared. C squared equals 81 plus 81. C squared equals 162. Take the square root of both sides. C equals the square root of 162. So then from here, I have to think, what's the largest square factor that goes into 162? Again, you might need to check your work, plug and chug. Like, is it 16? Is it 36? What is it? Well, it turns out it's 81. So the square root of 81 and the square root of 2. Weird how they're all the square root of 2. I wonder why. All right, and then this last one, it makes the pattern a little bit more difficult to see. This is kind of a challenge problem, but the pattern's still there, still exists. Technically, you might be able to solve this problem in 2 seconds if you figured out the pattern. But that's radical 3. Call that C. So we're going to get C squared equals radical 3 squared plus radical 3 squared. Now, what I like about this problem, it's a good review of simplifying with radicals. Square root squared, square root squared. They just undo each other. Remember, they're going to disappear, so you're going to get C squared equals 3 plus 3. C squared equals 6. And C equals the square root of 6. In parentheses, I'm going to put radical 3, radical 2. We don't need to simplify this. This can't be simplified. C is just radical 6 right here. But just a little bit of a challenge problem. All right, so there is a pattern. Did you notice the pattern? Maybe you're shouting it out right now. I can read some of your guys' minds in the future. I see some of you guys do see the patterns. A good job. All right, so looking at the sides of all the 45, 45, 90 triangles on this page, can you recognize a pattern? All right, explain words and symbols. All right, so what we got, this is a leg, this is a leg, and then this is the hypotenuse. All right, so this might shock you, this might be difficult to comprehend, but the leg equals the leg in this isosceles triangle. And then the hypotenuse, if whatever the leg was, the hypotenuse is just that number with a radical 2 at the end. And if you noticed above, like, well, let's just look at number 3. Well, legs were 9, hypotenuse was 9 radical 2. All right, 3, 3. Hypotenuse was 3 radical 2. 4, 4, 4 radical 2. Even in this other one, radical 3, radical 3, we got radical 6, which is also just radical 3, radical 2. So we can write it also like this, where leg equals leg, and hypotenuse, I'm just going to write hype equals the leg times radical 2. All right, so that's that. All right, that's the pattern. All right, in the next video, we're going to go in reverse, where we have the hypotenuse, and then we got to find the legs.